Hi, this is Stefan Bayer and this is part 1 of my blockchain security video course. In this first video, I just want to give an overview on why I think blockchain security is important and which aspects we have to look at when designing a blockchain application. So let's just get started. So there's a question here which I'm asked occasionally, and it says, are blockchains secure? And my answer to this is yes, usually. And I put the usually there because blockchains are secure as long as we're talking about the underlying cryptography and the protocol level. If we are using a relatively well-tested blockchain and a large blockchain secured by a lot of computing power, such as Bitcoin or Ethereum, we are generally secure. The cryptography has never been broken and the protocol works fairly well. But on the other hand, the digital assets that we represent on the blockchain, they are not secure. So this is a bit of a conundrum here. So because blockchain is all about digital assets, if we are using a blockchain, there's usually some form of cryptocurrency involved. We might be using a token. The token might represent a share of a company, some real estate, or something else. But usually we're moving money around or something that has some value. And if these digital assets are not secure, then obviously that's a big problem for blockchain applications. And just to back this up, here are some facts. From 2018, last year, that there was one report that suggested that during that year, $1.7 billion in digital assets were stolen or lost. Now, of course, this number has to be taken with a pinch of salt because depending on which report you read, you get different numbers. Basically, that's because there's no central place to report these incidents, and there's no one knows the actual number of dollars stolen every year. But we can agree it's a lot of money that disappears. And another worrying fact is what was reported in another report I read, and that's that there have been two groups identified that seem to be responsible for a large share of these incidents. And again, it doesn't matter if it's really if it's two groups or seven. What is important here is that it's become a business model, and there's professionals dedicated to spending a lot of effort in trying to steal cryptographically secure digital assets. So that's obviously worrying. And let's just look at the security concerns that are involved in blockchain applications. So first of all, unique to blockchains is the fact that we're using smart contracts. And that's often the case. I mean, even in Bitcoin, we have scripts, even though they're not called smart contracts. But usually when we move assets around on a blockchain, some smart contract is involved. Most tokens these days are implemented on Ethereum in the form of the ERC20 smart contract. And there are other smart contracts that move these tokens around and interact with them. And it's very difficult to make smart contracts secure for a number of reasons, which we'll look into detail in another video. But basically, they hold a lot of value, are transparently visible for anyone involved, and once they're deployed on the blockchain, they cannot be changed, so bugs cannot be fixed. And that means that it's very hard to develop smart contracts without any security issues. And next, there's off-chain code. Well, the smart contracts are actually a very small percentage of the code base of most blockchain applications, because in order to interact with the blockchain, we usually need a number of layers of code involved. Usually there's some databases, there might be some key management going on, there might be some APIs, some user interfaces, web interfaces, and all this code shares the traditional cybersecurity issues that normal code has. And there's nothing specific about this type of application. Just because there's a blockchain below doesn't change much, apart from the fact that we're usually dealing with private public key pairs. But it's just like any other code. There's security issues there. The same goes for infrastructure. Blockchain software needs to run infrastructure. There's blockchain node software, the client software to connect to the blockchain, has to run an operating system. It has to be connected to a network. There might be issues with the security of the operating system. The network might be poorly configured. APIs on the actual node software might be exposed that shouldn't be through some port that should be closed. That sort of thing can go wrong there easily, and that's also a way funds on the blockchain get lost quite frequently. And last but not least, there's a human factor involved. And as every cybersecurity analyst will tell you, humans are the most critical element in the cybersecurity chain. Whenever there's a human involved, there's a trade-off to be made, because in order to make software usable by humans, usually have to relax security somehow. Example of this is how we manage private keys in blockchains. It'd be more secure to have a private key, the wrong number, written down and locked away somewhere. But that obviously makes it very hard for a human to use. So there's a trade-off to be made. And humans are generally lazy. They take shortcuts when it comes to cybersecurity. And they're also very susceptible to social engineering attacks, to phishing. It's easy, relatively easy for professional cyber criminals to get the passwords of someone by impersonating someone else. That sort of thing happens all the time, and if we look at these big incidents on major exchanges, that there are usually some form of off-chain interaction and humans involved. It's not the smart contract or the actual blockchain protocol that are attacked. Anyway, we'll look at all of these in more detail in upcoming episodes. For now, that's all I wanted to talk about in this overview.